Hey guys, hope everyone is doing well, and hopefully let me know if the volume and everything's okay. It's obviously been a pretty long time since I've streamed last, so I don't know if all the settings are okay. I will probably wait a little bit just to make sure everybody who's going to join can join, and then I'll start doing the reviews. I think I have enough to stream for a little bit. If not, I'll obviously ask if anyone else has something to throw up in the meantime, but I think I'm pretty good. Let me see comments. I keep wondering if I should submit something, but usually I'm looking for back and forth, and I'd rather do it privately. Yes, then probably not on a live stream if you want it to be private. Show for Science, this is Manny. I'll visit the MT office. Fantastic. Why did you change your name? I'm pretty sure it used to be the normal, like, M. Baines or whatever on YouTube. Hey, Fetty, how's it going? I submitted a PDF of the schematic rather than KiCad because I don't use. Is that okay? Yes. For schematic, a PDF's actually kind of easier because I can just open it in the browser. Hey, Sanji, you okay with my Git link? Sanji, I'm assuming you are Sniper, right? And if so, then yes, that is all right. Yes, you just messaged me, so I'll pull that up. If you can, oh yeah, you have a schematic PDF. Yes, that works perfect. Just because again, it's easy to open up in the in my browser. All right. Man, it's like I haven't streamed in a while, and there are not many people here. It's kind of funny. It's like it seems like channels who stream a lot tend to get a lot of viewers for streams and less for videos. And then channels like me or mine that do more videos and less streams get a lot less for streams. I guess it's just what people kind of become accustomed to, which is what it is. New haircut plus glasses. Volume is a bit low. All right. Okay, let me know how that is. I bumped it up a little bit. And yeah, that's true. It is Mother's Day. I kind of forgot when I asked on the channel the other day if people wanted to, where can I put this? If people wanted to come to the stream, a couple people said that it was Mother's Day, and I'm like, oh yeah, I kind of forgot. Hey, Dave, yes, it has been a while. Derek, streams are always a challenge. Yes, time zone, especially because it seems like I'm pretty split between Europe and the US. So they're like 8 hours apart, ballpark, and they're ahead. So it definitely ends up being a weird time. Yes, volume is very low. I can bump it up a little bit more. Let me know how that is. That should be quite a bit louder. It's starting to show that it's clipping a little bit on OBS, so hopefully it's still all right. Can you tell me the owner's name of the chosen design? I can, like, for the board submissions, I mean, yeah, I'll tell you whatever they have submitted. Daniel says it was fine earlier. Well, is it clipping now, or is it still okay, just a little bit louder? Okay, let me see. Video and audio are good. Okay, so I guess it's not clipping, so then presumably it is okay, hopefully. Okay. I didn't say it earlier. Bit of a cool temperature wise. Yeah, it's just the camera I have set up right now. And also, to be fair, this entire space back here is all blue LEDs, so it's actually pretty true to what the color is. It's kind of annoying back here, but it makes it super easy to see everything. So give it a maybe like 3, 4, 5 minutes until I'll start doing reviews. Anyone have any general question or anything like that? Daniel, you have a lot of video production equipment but no videos. Hey man, I've been trying to do one a month-ish, roughly. It just sucks because it's like, especially with like the EMC and other stuff, it's like they're so time intensive to make, like 20, 30, 40 hours, and work has been super busy. So that's kind of been a pain lately. But we'll see. Maybe it'll get better. Okay, there maybe a little bit better on the color. Hey, PowerPath, yes, it has been a hot minute. You need to hire someone to do your job to concentrate on YouTube. Yeah, I know, right? It's like I tried finding someone to do editing, but it's like I can't really, because a lot of it's in my own head, like what the actual graphics need to be. But we'll see. No plan for quick videos, quick tips and tricks. Yeah, I have a few other ideas, but obviously the other thing that's tough is nobody is kind of suggesting a lot of topics, so it's up to me to come up with the topics, which is fine, obviously. I mean, I should be coming up with most of them, but it's just kind of hard not knowing exactly what people are interested at the current time, so definitely suggestions help a ton and are much appreciated always. Dave, any plans to join a MakerCast? Yes, I want to, but it's normally when you're talking about a project you're doing, and I haven't really had a specific project in a while. But maybe if I get one in a little bit, I will. PowerPath, please make some videos on EMI IMC. Yes, I have two. I have two in the works for that, actually. And this is the PCB for one of them. One of them is going to be the importance of like layout versus decoupling capacitors. So it's going to show the difference between a well laid out board without decoupling capacitors, a terribly laid out board with decoupling capacitors, and just kind of compare. And then another video is checking the impact of a buck converter with a snubber to see how it affects any ringing. So those two, I've got the boards set up. I just need to get kind of the footage and everything going. So those will be coming soon, hopefully. Why not ask in Discord if you want? I have 5 ideas. Then you can make some polls for next video. If you need a topic, please make a poll. Yes, I mean, I tried to ask in the past on Discord, and I get some ideas, but not a ton. But yeah, I can do another post asking. And if you have 5 ideas, send them over my way for sure. Derek, your existing EMI-IMC is pretty good, but I'd like more details on actually implementing any suggestions offered, i.e. calculating filters, etc. Okay. So, yeah, I can do something like that for sure. Are you thinking on like conducted, looking at like buck converters, or radiated with maybe some like, I don't know, some switching signals or like microcontroller clock, stuff like that, or just anything like that? But I like that. Definitely, that sounds good. Possibly high-powered LED project, that considerations for heat. I think you have experience there, right? Yes, literally for like the first 2 years of running this company, I swear like 3/4 of the project we did were LED boards. So definitely can do some work with that. The problem with those is they become kind of expensive to do and hard to assemble if it's like a full driver board, or a full panel. But yeah, I can consider those. What's the actual utility of electrolytic capacitors compared to ceramic, other than electrolytics can have higher capacitance? Obviously, what you just said is kind of the main difference, but the other really nice thing about electrolytics is they have a lot higher series resistance, so they can help damp the response, where if you have a ton of ceramics, it's so low impedance with so low series resistance, you can get some really nasty ringing. So you can either put a big electrolytic to help damp it, or if you do need just ceramics for size or reliability, you can just put like a series resistor in between in series with one of the ceramics, and it kind of does the same thing. So those are kind of the main issues or the main reasons, but obviously electrolytics can get way bigger. If you could, EMI, EMC filter design would be great, probably both, but most recently I've been working on iron out some buck designs and filtering TIS map notes, but it's easy to get overwhelmed. Yeah, sure, and like the snubber board, that obviously is going to be super applicable to conducted emissions also, so that will be right in line with that too. Johnny, good evening, ladies and gentlemen. How is it going? Your EMI MCVers are really great. I appreciate it. Okay, so I think now I'll go ahead and start with some of the reviews. So let's do... All right. All right, so the first one is kind of super simple. All it is so Ron submitted it, trying to drive 12 or 24 volt DC solenoid from a microcontroller like a Pico. It'll be statically driven, not PWM'd. He says duty cycle 30 milliseconds on, 70 milliseconds off. So what is that, like 20, 30 hertz? I know he says it's not PWM'd, but... Oh, you can't see? Oh, okay. I was going to say, Daniel, what are you talking about? I'm pretty sure I switched it over. It is PWM to some extent because it's driven on a pulse. I'm assuming it just means fast. I like the idea of using opto to isolate the solenoid from the microcontroller. It works, but the limited drive current from the Pico may not fully illuminate the opto. The low value of R2 may slow down the gate charge time. He also wants to PWM a vibration motor. Audible PWM is okay. So he submitted it. What program is that and what does it do? It's WordPress for websites. I don't know exactly what you're referencing. So for this, what I did is threw it on Faustad, which is a really cool like logic circuit simulator. It doesn't do anything crazy, but it's nice for really simple stuff like this. So basically all he has is a signal from his Pico driving an optocoupler, which then has the MOSFET, which is normally pulled up to, I assume, I don't really understand how this is going to be 24 or 12 volt, why that's there, so I just kind of got rid of it since it's not really relevant for what he's talking about. So I just have the 1K resistor to pull this to 24 volts to complete it down here, and then the 1K pulls the gate of the FET down, has a diode to have flyback protection, and then he has the solenoid just drawn as an inductor. You obviously need some sort of series resistance there, and I don't know exactly how much current this draws. He didn't say. So with 220 microhenry and 100, I guess we can maybe lower that a little bit. So this is half an amp, doesn't really matter. So he said it works as is. As you can see on the simulation, it works. As for his questions, I don't know off the top of my head how much. Oh, he said 1.5 amps. So not that it's going to change anything. And I don't know what the inductance value of it is, but we can lower that a little bit. Oh, and we get some nice oscillation with it ringing through here, so I don't really want to bother playing with that. So we'll just, we'll just go back up here because it doesn't matter what the current is because it's not tuned anyway with the inductor. So his first question was, what if there's not enough drive current to turn on the optocoupler? I don't know how much a Pico can provide right off the bat. Most microcontrollers are 5, 10 milliamps, somewhere in there. If it is an issue that it can't turn it on, the easiest way is just to put another MOSFET up here and have the Pico turn on the gate of that FET and have the FET drive this. So then you can drive it at whatever current you want. That's typically what you would do. As for using a optocoupler to isolate this side, it depends if this power rail is completely separate from the power rail that the Pico is on. If these grounds are completely separate, as in a separate power supply or something like that, then yes, this can be a good idea. But if they're connected somewhere else, this really isn't doing anything. And normally the only time you would use an optocoupler is if you're kind of driving like a PFET or something like that. So it just depends. It's not inherently wrong how this is. I just normally, they will be completely separate, he said, then yes, this is a good idea if it's required to have it completely separate, because then obviously none of the noise gets coupled onto the Pico other than just actual like EM radiation going to it, which is cool. As for any other suggestions, I mean, you could have a TVS on here to help prevent any voltage spikes on the gate of the FET. If the FET can't have 24 volts on here, I think that's what Fetty said. Maybe if it's only 20 volts rated, you could throw there's 100 different ways you could do it. You could have a little voltage divider here to have it drop to 20 volts or 16 volts or 12 volts. You could have a voltage reference TVS diode. Really, at these low switching frequencies, it really doesn't matter. Your TVS here is fine. You could also throw a ceramic to help with some high frequency noise. You could throw a ceramic across here to help with that. Really depends. It depends on how noisy everything is on the solenoid side. But as a start, I don't see anything wrong here. Pretty standard drive. Any questions or any other input? And just as an aside, like other than this one, all of these I literally haven't looked at other than just to throw them into tabs. So I am going to guarantee you that I'm going to mess up on stuff or overlook something. So if you guys see something that I don't, or if I misspeak on something, obviously let me know. This isn't like a pre-planned review session where I have notes or anything. So I'm kind of seeing it the first time, as are you guys. But I think this one's pretty self-explanatory. But yeah, let me know any questions or any thoughts on this, and if not, we can jump to the next board. The two 1Ks are already a divider for the gate. Well played. Yes. So there already is a divider. I didn't even realize that. Yes. So it is dropped to 12 volts. So obviously that's going to be fine if you're driving that. He said also wanted to have this circuit work to drive a 5-volt motor. Well, then now you have to obviously completely change the circuit. You have to have some way to give this 5 volts over here, which a regulator or something. Oh, yes, Daniel's right. Open for 24 volts, shorted for 12 volts, because then that affects what the value of the divider is. So like I said, I have not looked at these very much. So yes, if it's shorted or if it's open, it's going to be divided either by the 1.5 or paralleled with the 1.5 and the 750. So that adjusts the voltage on here. But yeah, if you want to drive this at 5 volts, then obviously you have to have a 5-volt rail somehow. The easiest would be to have a 5-volt divider here, and then you can still have the 24-volt drive the gate of this and just have these separate. So you do something, oops. So you do something like that. So now you're driving it at 5 volt and still using the 24 volts or divided to 12 volts to turn on the MOSFET. Supply would be 5 volts instead of 12 or 24. Bit odd values, napkin. Supply will be one of the following: 5, 12, or 24. Yeah, I mean, either or. You drive it one way or another. But yeah, I think that's fine on here. Obviously, if anything else comes up, let me know. But yeah, so I think that's it. And there's a little bit of ringing just from the capacitance and the inductors forming a little LC circuit here, which is causing that ringing, which is back to the snubber circuit I was talking about on the buck. Okay, so the next one is from Fetty. So first of all, thank you. Most important thing, how professional, any potential issues, PDF block diagram schematic. It's 4-layer stack up, signal VCC, inner ground, ground. So first off, bonus points for doing the Rick Hartley stack up where inner 2 are ground and outer is your signal and VCC. That's pretty much exclusively the way that I and we at work do circuits, do stack ups now. It's super good. Input panel 15 to 30, 20 volts, max current 5 amps. Operating frequency of the buck is 39 kilohertz. Okay, that's super low. Maybe that's a typo and it should be 390. 1.6 standard copper, 1 ounce standard. If it's all on 4, maybe a little bit thicker. So as a disclaimer, I have never done a solar panel board, so I'm going to be pretty limited on here with the solar side, but I will see what I can do. So I like this, having the block diagram here. That's kind of nice. So battery goes, what is the battery voltage? Did he say? He said 12 volts, didn't he? Battery 12 volts. So whoops, we have a battery which goes to a 12 volt buck converter. Why? If it's a 12 volt battery, why does it go to a 12 volt buck? So that's the solar panel fuse. So solar goes to, oh boy. I am not following this. On a schematic, so first critique here, I don't like schematics where it's completely split up. I like having some upper level where I can follow things. But he says gate driver. What do you mean? If you have 12 volts on the battery, why is it being bucked to 12 volts? It's not doing anything if it's 12 volts here, 12 volts there. 5 volts, where is 12 volt DC? So battery goes into here and 12 volts out. Yeah, something's, either I'm misinterpreting something or something's wrong here, because you wouldn't have 12 volts from the battery going into a buck converter to then get 12 volts out. One, that doesn't work, and two, that would be needlessly inefficient. Where's the 12 volt cell is often 9 to 15 volts in practice if it's lead. Well, it won't be 9 volts because that would be super low, but yes, it could be 15 volts, but if you're trying to get 12 volts out of it, you would probably want to use a buck boost because it could go below 12. So it is 14.4 volts, so I guess that's it. I would probably use a buck boost just because if it ever gets below 12, but I'll assume that that's fine. So bucked down to 12 volts on here. Not a ton of capacitance on the input side. Considering this is coming from a battery, you obviously don't have to worry about conducted emissions really, so it's probably okay. I'd still like to see some ceramics on this net just to help with that some. Everything else here is fine. Again, you could probably have some ceramics on the output to cut down on the ripple depending on what it's going to, but that looks okay. Now the 3v3 buck, is it the same buck? Yeah, same buck, so same setup, same critique. I'd throw on some ceramics here. I'd throw on some ceramics here. Nothing else is really going on there. Nothing is going on here. An external watchdog, love to see it. So anyone who doesn't know, basically this is just an external watchdog, so he has to ping it every so often, and if he doesn't, then it will trip the reset and restart the microcontroller, and that's if it gets stuck in like an infinite loop or anything random happens. They're really cheap, and they add more like redundancy than just using the internal watchdog. Something that we recently did on a work project for a like really robust like industrial control board with like multiple boards talking over CAN bus is instead of using an external watchdog, we used a couple extra microcontrollers, and the microcontrollers, while also interfacing and servicing like sensors and stuff, they acted as the watchdog, so we would talk over UART to each other, and if we didn't get any communication, then we would trip we were using a microprocessor on it, we would reset the microprocessor. So there's a lot of ways you can do stuff like that. Definitely like to see that. Load switch, I don't know what this is used for, but it's just to control on-off. It's just internally, usually like back-to-back MOSFETs. So super cool. Super cool. I don't know why I said that. It's just a load switch. I was still happy to see the watchdog. This just labels and connectors. ADC, analog in, I2C. Where's the ADC? What's it doing? It is detecting the input voltage from the solar panel. It is detecting the voltage on the shunt for the current sensor, and it's detecting the battery. So the input voltage channel doesn't have to be accurate. The output voltage channel doesn't have to be accurate. The input current channel probably has to be accurate depending on what the current sensor is. Where is that? Oh boy. Or is that just reading from a shunt? Oh, you're saying it's lagging? No, I don't see. It's at least not yelling at me that it's lagging. Daniel says yes. Okay, cool. So, battery out. Current is detecting through here. That's the voltage on that side, so that's not the current. What is A3? A3 is detecting the current or voltage there. What is A2? A2 is oh, so it's a ACS, one of the Allegro parts. So that, I believe, has a pretty high voltage output on the internal ADC. So I don't think that needs to be super accurate either. So I don't think any of those the ADC channels are super important. But yeah, I think that's all fine. Okay, ESP programming here. So Daniel is going to make a comment in the chat about why you don't have to do this auto programming circuit. I still do it on every board that we do. I guess you don't need it, and I've heard from multiple people, but Daniel is the main person who tells me that you don't. One day I'll figure out what he does and why we don't need it, but until then I'll keep using this. So you are using USB to UART to program the ESP32. I personally don't like that just because you're paying for a part that's only on there to program it. I like to just expose the UART and then use a tag connect connector, but it depends on your use case. So up to you on if that's important or not. I don't see any well, excuse me. Still coming off being sick. So, what was I saying? There's no TVS diodes on the USB, which I would like to see, or some series resistors. It's only going into this USB to UART, so it's not the end of the world, but I still always like to see that. I think you do. I don't use those ESPs anymore. Oh, is this the old school room? Okay, yeah. Right. On like the new S2s, S3s, all of those, I guess, is where you don't need it. Right. Cool. This is USB 5 volt to 3v3. I don't know why he's taking it from here and not anywhere else on the 5 volts. I'm guessing that's just to isolate so we can program this without anything else being connected. Someone asked, Sanji, how do you do the MPPT? It didn't say if it has MPPT on here, so maybe it's just direct to it. Again, I don't even want to comment too much on the solar side just because I'm not the right person to talk to. If I end up doing a project at some point with solar, then I would know more. So, yeah. And I hate the look of the MOSFETs that do it like this. I like being able to physically see the MOSFET picture on there and just have the extra pins. But obviously that's, yeah, I like seeing like this. But that's obviously user preference. He says there is MPPT, so where's our solar? So our solar comes in here, has a polyfuse, divides down to sense the voltage, goes in here, and then we have input caps. It goes into our shunt sensor. The output goes to our ADC. We get our output VCC. Wait, no. That is the external power for the shunt sensor. It goes here. Then we have our MOSFET control back to back, presumably. And then we go into our, oh boy. Yeah, so then here is, what is this? Okay, so that's our half-bridge driver, presumably for the MPPT side, which drives our two FETs, the high and then low, which goes to the output, which then goes to, or goes out here into the battery. So yes, then this is our control for the MPPT side, which again, not going to get into that because I will not do that justice. So I think that's the gist of it. Now for the PCB, not going to go too much here because it's kind of hard without having the actual files. Right off the bat, like the use of the big pores where you can. Technically, your keep out needs to be bigger for this. It'll still work, but you're going to lose some range, and it'd also be better if it's sticking out. But that's not the end of the world. No real stitching vias anywhere other than just where you deemed them necessary, which is okay. I still like to have stitching vias. They're rarely going to hurt you. Internal ground, and then bottom. Not a lot of traces on here, which is fantastic. So overall, without seeing actually where the, oh, no BLE or Wi-Fi used, then clearly that does not matter. Just quick look at this. The layout looks really good. Anytime you're not using the bottom layer much and keeping everything on the top, it's inherently should be pretty decent just because you don't have a lot of cuts, especially with it being 4-layer. Let's see, anything. USB 2 route looks fine. Craig asked why use an ESP2 if you don't need BLE. I've done the same thing, just in the chip shortage. There were always ESPs around, and it's a decent microcontroller price-wise to have, especially dual core with RTOS. It's pretty helpful. Everything else, yeah, looks fine. Don't see anything that sticks out. Yeah, so I mean, overall it looks fine. The biggest suggestions I would have just from looking at it is, like I said, add some filtering on the bucks, input and output, even though it's not going to matter if there's conducted emissions, but still nice to have. It's not going to hurt anything. Yeah, anyone else have any questions or anything related to this or whatnot? If not, I'll jump ahead to the next board. Craig and Sinji are talking. What's the problem exactly with stitching vias? There aren't. That's what I'm saying. I would just sprinkle stitching vias throughout to have the ground planes be lower impedance between everything. It looks like you kind of have a via by every ground pad, which again, you probably don't need to, but there's no negative of having stitching vias really. There are sometimes, but not in a board like this. So just adding them helps. There's some plugins you can have that do it directly. But yeah, I think that's it, Sinji. 15 video ideas. Let's take a short intermission and see this. Ethernet hub switch, probably not going to do that. I'm still have PTSD from the USB. I have thought about this. That's just a huge project. Interleave buck, same with boost. Universal mains to USB, definitely thought about doing that. Power filters, yep, that's what people are saying. PCB way ordering, yeah, that could be decent. How to cool FETs, beer talk, connector, that's a good idea. Back-to-back FETs, not bad. Flyback, that'd be cool also to test for like EMC. Talking how you entered the business, yeah, I could do something like that, but they tend to not get much input just because people like to hear more about the designing. Workstation tour, advice how to documentation. Yeah, I like all those. I appreciate the input. Someone should make a shotgun stitching. There is one. It works really well. Yes, Daniel, it is. It has randomized vias. I don't know if I have it on this computer. No, but there is a plugin that does them randomized. Okay, so next one is Daniel's half-baked project on the shelf. Never did. Controlling 240 volt resistive loads, 10 amp fused inputs are 24 volt AC momentary inputs, 24 volt SSRs. This is the relay board. All right. Whoops. I think this is this board. So let's look at the schematic in a shotgun circle. I mean, not specifically, but you can randomize them. I don't know exactly what you're referring to with the shotgun circle. MicroType, how did you lobby it to work on my end? It takes ages. Yes, sometimes on really complex boards it won't work. But if I just play around with the settings, it seems to usually work. Is that a jumper? A net tie. What does that look like on the board? So yeah, it is just a jumper. Interesting. Never seen that. Okay, so power in. 24 volt AC comes in here, gets rectified by a full bridge rectifier, and then capacitance. Obviously here you can simulate how much capacitance you need, but it's honestly pretty hard to calculate that, and you end up wanting to test it. So these are obviously just for the regulator more so, and then this is to stabilize the rail. So assuming that's enough, that all looks fine. It goes into the buck, which bucks it down to 5 volts. Just semantics. I usually like the boost to be up here with the boost net up on this side, like that. I don't know why, it's just the way I've always done it. Daniel's schematics are like really good, like laid out wise, so I like to find any little thing I can to critique whenever I can. Net tie here, so is that another one of those little, I like that idea. It's a little bit less intrusive than having like a jumper, which is what I normally do. Output, so here you can see what I was saying in the last board. Not only is there some bulk capacitance, it also has this as ceramic, so it's going to cut down on the ripple. You just have to sometimes check on the control loop for the regulator, because if it relies on ripple and you cut the ripple too much, it's going to make this uncontrollable, and you might have to have what's called like a ripple injection circuit, where it's like an RC to boost it, or you put an inductor here and smooth out the voltage, the ripple on the output. But it just, again, depends on the control loop. Connector to control board, depending on what all this does. Probably nice to have some TVS diodes or series resistors, PCB temperature sensors, just over I2C, nothing fancy here. 8 SSRs, so we'll go into these in a second, but enable, so turns the solid state relay on, and then the output, what voltage does this take? So something I like to do is I use the hierarchical blocks when you, magnetizer, vital PCB antennas, FETI, when you need ripple on the design. Well, you never need ripple. It just, sometimes the feedback has to have ripple or else it's not going to be able to regulate. Derek, those AP6 bucks have a peculiar where they switch from PWM to PFM. I hate that. I hate buck converters that do that. I like the ones that have it controllable to where you can make sure it doesn't go into discontinuous mode and it stays and forces it, but they're way more efficient at low frequency, so it is what it is. So what I was saying is I like to have all power also shown here so you can see that it's being powered by the 24 volt AC, but that's just up to whoever is designing it. Input sensing. So this is the pass-through. Actually, I'm going to try to stay on the outside. So it detects and senses here, or... Yeah, see, I like having these... where are we sensing the current? Or are these just logic level? Oh, these are just logic. So we're sensing these as inputs. Okay, got it. I thought these were power. So all we're doing here is detecting when it's on or off and then triggering the optocoupler and then detecting what it is on the output side, pulling it up. That all makes sense. Using bidirectional here because presumably that is 24 volt AC. So that is all fine. And then what he does here, I think he had asked me about this a while ago. You use a cap here to stabilize the switching, so you get an output here that is constantly high or constantly low and not high-low for the peak of the AC signal. I've done that on like a thermostat, which uses 24 volt AC, then goes into a GPIO expander. Pretty simple here. Talk to it over I2C. Adjustable I2C addresses, all looks fine. And I'm assuming he's using, yeah, just the solid states for the 24 volt AC. Whoops. So they are triggered just by turning this on, and then it's powered. Another thing I would like is this being on the top. I like all power being on the top, all ground on the bottom. Again, just personal preference. Nothing crazy here. And this is being driven by what? The enable here, depending on the drive of this and frequency or how that is, you could put a series resistor on the side closest to the GPIO expander. It's not going to hurt anything, but it can only help. But it's probably not needed. And now our relays, so these are the big boys at the 250 volts. They're enabled by, oh, these are enabled, turned on here. Oh, they're tied together. Okay, got it. And the relays are driven, as you would expect, by some sort of MOSFET drive. He is using a P-channel FET and driving from the high side. I always like driving everything I can from low side if it's possible. Again, personal preference. I just do that because NFETs are more available. There's more of them. They're cheaper and more efficient typically. But for something like this where it's just triggering something, it doesn't matter. And he's driving it from the 5 volts, which is also what he is controlling it with. So it doesn't matter about needing a boost, which is nice. And nothing really here. There's nothing on the output side in terms of protection on what is being triggered here. That is a whole art in itself. You can have a snubber with an RC. You can have a, you can't have a, this is AC, so you can't have a diode to protect it. That's something I won't really get into because it's so dependent on the application and what standards there are. But a lot of times you put something here to help protect the contacts burning closed or sparking, and to help any emissions when it switches, because right as that touches, there's a lot of EM interference that is produced just because it's not closing at one specific time. It usually bounces a little bit. But that's an art in itself, and that's something, again, I don't have tons of experience with on the main side, but something to just keep in mind. How to calculate the RC snubber on the AC side, again, that's something that is not my forte. There's a bunch of app notes on it and some UL standards that dictate what it should be. But yeah, overall, looks good, nothing crazy here on the schematic. I think Daniel said that he didn't have this built, so I can't ask if there were any issues with it. Derek asked, that's something I'd love to see more info on. Okay, I can see about doing something like that in the future with some testing. Now for the layout, we have 4 layers. He is doing, inner 1 is ground. Inner 2 is not used. Insight on that, Daniel? Maybe that's where all his isolated lines are going, I would expect. I'm not exactly sure. He says signal, ground, ground, signal. Yeah, I think you forgot the ground part. Oh, come on. So, help you out there. Now we have ground on... Wait, why is it not showing them? Is it not connected to ground? No, it is. Whatever. Well, not relevant. Okay, so top layer, we have our 24 volt AC. This, let me split this. We have our rectifier here, so then we have our 24 volt AC, which goes on the input side. The output goes to the rectified. Holy crap, that is a big capacitor. Holy cow. And then it goes into the buck, the input. So the loops that we want to look at, the first one is the loop from our input cap to the ground and back. And rebuild pour. I thought I did. Oh, I guess I forgot to do that. That was probably what it is. Yes. There we go. So now we have ground on both. So we want to look at the loop size from the input caps back to ground, which, as you can see here, really couldn't be any smaller. If you really wanted to get it a little smaller, you could move these here and then just adjust the stitching so then it is as small as possible, but it's probably fine as is. And we don't include this cap in that loop because for the high-speed switching, it's not relevant. The parasitic or the series resistance in it is way too large to make a difference, so it doesn't really matter. And then the next loop we look at is on the switching side, or actually we can look at the boost. We want this loop to be as small as possible, which it is, so that is good. And then the last one we kind of look at is the output and the inductor switching node to be as tight and small as possible, which it is, so that all looks fine. Now, one thing I would say that probably won't be an issue, but I'm not a huge fan of, is the feedback node. That is really sensitive because if there's any noise induced into this, it's going to be making the regulation unstable, and it crosses right next to the switching node, which obviously it's not as bad as if it went under it, but that's still not ideal. So maybe I would consider going a little bit wider around here or going on underneath and going around here, something like that. It doesn't matter how long it is because it's a super high impedance input. So that means there's literally no current going through here. So it can be super long. You just don't want it to have any noise. And that's a little closer than I would like to see, because the switching node is the noisiest node in any buck converter, so you want to keep it far away from there. But with how small this loop is, I'm sure that's not going to be an issue, but just something to keep in mind. Now, everything here really doesn't matter. The isolation on the 24 volts here really doesn't matter. What matters is the 24 volts on this side. So here's our relay, which is driven right here. The diode is as close as possible. Fetty says no need for pi filter. I mean, you're powering all of this from a 24 volt AC source, which has a massive cap damping everything, and then it also goes through a full bridge rectifier. So I think it's going to be sufficiently damped, and it's a super tight layout. But yes, obviously having a pi filter in here wouldn't hurt, but I don't think it's super necessary, or I guess technically it would be after this. But yes, it obviously wouldn't help or wouldn't hurt. So our drive here, the diode's as close as possible, which is good. Now, presumably this is on the bottom layer. and assuming Daniel has done his math and calculated what his creepage and clearances need to be, that all should be fine, which since it's limited by this, I don't see an issue here. So yeah, everything on that looks fine, nothing crazy. And if you did want to get a little bit extra isolation on these, again, it doesn't matter because this is a plated through hole. You could put one of these on the top layer, one of these on the bottom layer, but your arcing point are these anyway, so it doesn't matter. And since this isn't the switch side, it shouldn't arc anyway, but it's okay. Could the copper unbalance on D9 hurt during assembly? Copper imbalance. So I have never experienced tombstoning on anything bigger or the same size as an 0603. So what are these? Are they 805s? They look like it. Yeah, 805s. So this diode's roughly the size of an 0805, probably closer to an 0603. So I don't think this is going to tombstone, but technically you are right. This should be balanced. So these should be a thermal to some extent. Let's do 2 and then 3 something, and then rebuild, and then we get that. So now it balances it a little bit better. But again, I've never had that an issue unless you get to 0402s. There's no mask on them for the good old tin pour and traces, but I have those cut out. The clearances should be okay. Yeah. Oh, I didn't even notice. These are cut out. So yeah, that should be fine. I completely missed that. So that makes it air gapped between these, which helps a lot. And just to expand on what Fetty had said, copper otherwise is pretty well balanced, so I wouldn't expect this to warp at all, which is good, because where the copper is, it's pretty split. So yeah, overall, super nice layout. Nothing crazy here. So yeah, unless anyone has any thoughts here, I think we can jump to the next one. So let me know if anyone has anything. Okay, it appears that nobody does. So let's jump to the next one. So this is Carl's, and we got a big device, USB-C PD with another USB data, and pass them together as one to a phone port. Okay, when in PD, the connected CC should connect to whichever CC is active, the others don't matter. Oh boy, this is a meaty one. Issues when U4 receives on one of its switchboard higher than doesn't seem to stop the voltage, but lets pass through the other side. When U3, okay, we'll see. I'll do my best here. There's a lot going on. I don't know if I'm gonna have time to fully dive into it, but let's first see just kind of the gist of it. So again, I'm not a huge fan of everything being kind of blocked. Like, I don't know what's going on here, and they're just separate blocks. I much prefer, and Daniel's isn't complicated enough to really show it well, but I much rather have where you do use blocks to have actually them shown what they're doing on the outside, just because it's hard to follow. So we have a charge through only port. So this is what's providing the PD delivery. He said PD, right? Yeah, PD. So this gives us power. We still need the D minus, D plus to talk to our controller. This is our data port. So presumably the data goes from here to here, but it's powered by this port. which I guess I can see a use for. I don't have one right off the top of my head, but sure, I can buy that. And he has an ESD block, which is presumably for this. Again, I would like to see it here. You have room. That just abstracts it out too far, and it confuses me, and it confuses people who don't know what's going on in it. Has a ferrite on the V-bus. I don't really like that, but he has it just as a placeholder so we can test it, which is fantastic. Shield on the downstream is connected. Every shield is connected to ground, which is okay. Depends on power flag on the shield side. You normally don't do that. Your ERC is yelling at you big time because you have so many power flags on the ground. There should only ever be one. Now the first block, let me first go to the ESD side. So ESD, like I figured, is just on all the signals. 1 second. Okay, we'll have to see how much longer my voice can last. I'm starting to struggle with talking. We'll see. So yeah, ESD is just normal. Shields actually aren't connected. That's why they each need power flags. Oh, ground 3, ground 1, ground 2. Got it. I don't know why you're doing it that way, but sure. Yeah, they're not gonna error then. Okay, so let's do the microcontroller side to make sure nothing crazy is there. So microcontroller, RGB, I2C, presumably to the PD controller. Nothing else crazy. Atmel ICE programmer. UART going. Injection protection. I like that. Injection protection. Yeah, nothing crazy's here. Now, high power, low power. Let's look at control next. Okay. Oh, you're just switching the CTC. What is CTC? Oh, I'm not able to search this. It's imaged. What is CTC? CTP. Oh, charge through port. Got it. CTP. Okay. So let me get nomenclature. Charge through port, CTP, DFP only, phone port, so PP, and data port. Got it. Okay, so this switches between, what is PC? Okay, what is PC CTC? Oh, is that the control signal? Yes, so that's the control signal. Okay. So, what I am seeing is this is just a digital switch. So it's powered. The microcontroller triggers on and off these switches, which, oh boy. Which maps which CC pins actually get passed through. So the charge through port gets triggered with the phone port, depending on the logic here. Okay. I think I can buy that. Crap. Yeah, I don't think I'm gonna have time to go through this. It's kind of hard to follow. Like, there's just, I don't know what would make this easier to read. It's just kind of tough to see. Let me see if I can look at specific questions. When U4 receives on one of its switch port a voltage somewhat higher than its VD, it doesn't stop the voltage, but lets it pass through to the other side of that switch. If it's lower than VDD, then it properly rejects it. When U4 receives higher than its VDD, I'm assuming that's just a limitation of the part, right? SN74. Yeah, I mean, it's rated for 5.5 volts. Yeah, I mean, why is it getting a voltage higher than this? Or is that why you're saying it's a 5 volt LDO instead of a 3v3? But a 5 volt source, 3. Yeah, I think that's just the limitation of the part, right? I don't think that's actually a issue. I think that's just how this works. You always have to have the VDD higher than whatever you're triggering. And also, this isn't TTL logic. It's based on whatever your VCC is. So depending on what that VCC is, that affects what the thresholds are. So you have to keep that in mind too. It's not a set voltage. So I don't know if that helps, hopefully. When U4, if there is voltage on CTP, when I remove the pull down, the voltage remains there. I mean, that's kind of normal, right? That's why you have a pull down. Because if not, it's just floating and it can be whatever you want. I probably wouldn't remove the pull down resistor then, unless there's another question there. When voltage appears on the PP side for any reason, Q8 seems to let a spike voltage through before it turns off. Q8. Q8. If there's a voltage on PP, Q8 seems to let a spike of voltage through. There's voltage on the PP side. It seems to let a spike of voltage through. I mean, you have it back to back. If they're both off, I mean, you shouldn't. I mean, yeah, if this one's off, you shouldn't have reverse voltage getting through. I don't really know, unless it's connected somewhere else. U3 is too complicated, but when U3 uses power, yeah, that's too complicated. Yeah, I'm sorry. There's just a lot here to be able to kind of go through. Sanji, this is something you need to check in a simulation. Yes, I would agree. And again, it doesn't need to be like a crazy spice simulation. This is where something like this, just logic-wise, can help to show it, because it's super useful for that type of stuff. But yeah, I would work on definitely cleaning up the schematic to make it a little bit easier to read and have all of these in little blocks. But cool concept, for sure. Sorry, I can't really be more help on that. Daniel says he threw the 3D view. So there's everything populated. Yeah, that's a massive capacitor. Very cool. Okay, so now last one on here. Oh, and she is a beast. Crossband handy walkie-talkie. Do we have what this is? Crossband, this and use where satellite works. This is probably another one that's going to be a little too complicated to go into a ton. Did you mention any background with it? Did you send it to me? Yes. Not the most complex I do with audio, both analog, so there's that plus RF. Okay, so we'll take a look at it. Okay, so ESP32S3. Tons of pins on here. So he is using GPIO or global labels for this, so it connects to all sheets, which I used to do a lot. I try not to as much just because it can get a little bit complicated with inner and outer sheets, but if you don't have any inner sheets, then it's usually not an issue. Input here, data, everything looks fine. Danger pins, I'm assuming those are the strapping pins, which if so, that's pretty funny. I'm pretty sure GPIO 5 is one too, right? But that's a funny way to do it. I've definitely screwed myself with that before. SD card here. Nothing crazy on this side. You could have some like hot plug detection or protection on the VDD side, but not a big deal. Nothing crazy. USB, so yeah, this, like I was saying on, I forget whose design, this is how I like to see the ESD right where it is, just because it's easier to tell. ESD diodes, presumably these are designed roughly for USB, so they're fast enough and low enough capacitance, which, as an aside, if you guys haven't seen the article, because I didn't ping everyone, that I posted a blog on ESD protection, I talk about some of that in here, which, as an aside, if you don't read any of it or all of it, just read this part. The bidirectional versus TVS diodes, super misunderstood. People think that a unidirectional diode doesn't protect in the negative direction. It does 100%. It's actually better than a bidirectional. Bidirectional is only if it's a signal that swings from positive to negative, like RS-485 or something. So just kind of something to take a peek at. So everything looks here. Again, ferrite bead, I'm not a huge fan of that. Just blindly throwing on, it can help, but it is what it is. Shield, definitely not a fan of this. I like, if you're going to connect it straight on, but it's nice to have the ability to throw stuff in there. Nothing crazy there. I2C's pulled up, looks fine. Now our power supply, this is an absolute beast of a little block. Ferrite bead is bad. It's not bad, it's just when you throw it on there and you don't really know what you're doing it for, it can cause ringing, it can affect downstream what can pass through. It doesn't just blindly block stuff because it can ring pretty bad on whatever capacitance is up or downstream. It's fine to have it there, but then you want to like test actually if it's helping or not, because a lot of times it can make things worse if you're not designing it specifically. But again, the fact that it's there, you can always just short it out, which is nice. Daniel, can it do ringing like how I said? Yep, exactly. So this is a buck. There's a buck, so I need to filter the input. Yes, but you should filter it right here, not just throw it right out here. And maybe on the PCB it is directly here, which if that's the case, it should be put right here, just to make it more apparent on this side. So the buck, we only have 10 mics on the input. I would like to see a little bit more to help with the filtering. I don't know why we're using 0.1 output. Oh, you're filtering out the voltage ripple. So this is what I said earlier. Presumably, this buck on the feedback side needs to have a little bit of ringing for stability, I'm assuming. Buck out right here. I mean, not really. Buck out's here. But okay. Oh, this is the switch node. Oh, it's drawn backwards. Wait. I'm confused here. TP 500. Oh, we got a Chinese part. Oh boy. Is that not TP 500? TP 5000. Because that sounds like a TI part. Voron UA. So translation done with Google Translate. Oh boy. Okay, yes, I guess that's it. So, sure, I guess I can buy that. So our charger goes out here, charges. That's weird that that's a current limit, whatever. So that charges our batteries. What kind of batteries are these? Because you normally don't want to just throw them in parallel like that. You need to have some sort of control between the two, if not balancing, at least something so they don't get out of sync. But no, I know the math is above. I'm just saying that's kind of a weird spot to do it at. I've never really seen that. So this is what I was saying. We've got our inductor here, which filters the ringing because it forms a pi filter through these. Then we have a switch here to I guess when this is disconnected, this gives us 3 volts. When it's connected, I guess the 5 volt isn't. And then this is giving us 3v3. I'm assuming something along those lines. Battery filtered, so that's what actually controls it. So then I'm assuming we have an enable pin or something here to do that. Standby. So I guess it's just when it's disconnected, which okay, I can buy that. So yeah, there's a lot here again that's just kind of hard to go into in such a short amount of time, but nothing seems overly crazy. Audio codec, more or less. GPIO 16 is enabled. Okay, so yeah, pretty much what I was. Whoops, I did not mean to do that. Oh boy. Okay, so now we are on the audio codec. So we've got a LC or pi filter here. Yes, 8388. I guess we're filtering this to have the output side to be cleaner. I'm assuming that's what we're going with. Okay, so that's what this is for. This is where you could also have a ferrite to help with the high frequency. Our audio jack in. Goes in here. Or is this... output, where does the output go? So we have our audio coming in here, right, left output, and then also a, I don't know why that says mic input is, oh, this is a dual purpose mic and headphone, that's it. So our output goes here, and then we have a mic input, which goes into this side, so it's taking in mic inputs, and it's taking in inputs from our ESP32, maybe? Or is that coming from one of our RF modules? Anyone have an idea? Both? Well, where is... I don't see where these are on the schematic. Okay, well, I'm assuming I'm just... lower left, he says. Okay, whatever. I guess it's just taking audio in from somewhere in here. In the audio block sheet 1. Audio block sheet 1. There isn't an audio block on sheet 1. Oh, right here. Okay, there we go. Got it. Okay. That should not have been that painful. Okay, so yes, it's coming from our microcontroller on the clock side, so on the codec side. So that's where our audio, digital audio is coming from. So yes, we have our input here, we have a mic input, or I guess the mic input's here. We have line inputs, so yes, tons of inputs, outputs, and then the output on here and here, which then goes to our audio power amplifier, which gets the outputs that I just mentioned, which goes in here and then gives us a amplified output with another filter on this side. And that is our volume control, presumably. At least it looks like. So nothing crazy there. Now, the RF modules, I don't know what this is, but our antenna with the SMA connector, we talked to it over UART. Audio, mics, pretty obvious there. Control, we have an RF power bus. Where is the RF power bus? Oh, RF power bus here. So I guess to, wait, no. That's obviously what I looked at. That's where this is coming from. Is this the only place it's connected? I don't know why you didn't just, yeah, I guess it's so you could name that net. That's what it is. Okay, you named that net, and then it connects there. Got it. So 2 modules, everything is connected here, same way. But yeah, yeah, I don't see anything crazy here. 1 second. Okay. Needed a water break. But yeah, everything here seems fine. Daniel Angiospace looked at it too. Did he? I don't know how you know that. Oh, reviewed by. Oh, very cool. I'm assuming that was a much more in-depth review than I am doing here. But yeah, nothing nothing seems crazy here. I'm obviously not a huge fan of like the Chinese parts just because it's hard to get support and see data sheet wise what's going on. So that's a little sketchy, but otherwise it seems fine. So yeah, main suggestions that I see, I mean, like I said, if this ferrite is for this, then it should be at this. What I like to do if I'm filtering buck converters like hardcore, I'll have a ferrite right at the buck and then a pi filter at the entrance of the board. So if you have 3 buck converters, you'll have a ferrite at the entrance of each buck and then a general pi filter at the entrance of the board. No other lithium iron phosphate chargers out there, and they're all linear. Negative. 1 second, I'll show you one. Give me 1 second. I'll try to pull it up. And I'm just going to go to my face here because I can't really show this board, but I'll at least find the part that it was. Oh, this is a linear regulator. Never mind. So maybe that is the case. I know it was definitely a pain to find that. So I guess that could be the case. but I'd assume there would be something else. But sure, I can buy that. Pi filter on input and output. He said he will do a pi filter on input. That's why. Yeah, but they're for different reasons. The pi filter on the input is for conducted emissions leaving the board. The pi filter here is to drop down the ripple. Depending on, like I said earlier, depending on the control scheme here, you could filter it without the pi filter and just lower the series resistance. But if it messes up the control scheme, obviously you can't do that. But pi filter will lower the ripple more. I'm assuming you wanted the lower ripple for the audio side, but to be fair, you're also using a pi filter at the input to both of these, so that pi filter is probably pretty redundant, but I guess it's not going to hurt. So yeah, I think that's kind of the bulk there. So I think there's another board that I was sent to review, but honestly my voice is kind of giving out. Does anyone have any general kind of questions or anything that I can answer before I call it a stream? If not, then I will try to take some of the suggestions on video. No layout on the board. No, I probably don't have the voice to do the full layout. How to size the inductor value of the pi filter. Honestly, a lot of that is simulation and testing. It really depends on what your transients are. If the transients are really high, if you use a large inductor, then you have to have a ton of capacitance on the downstream side. If the transients are small, then you can use a smaller pi filter. Generalities, the lowest I'll use is like a 2.2 microfarad. The largest I'll use is maybe a 10. Any bigger than that, you have to have so much capacitance downstream, it becomes not really practical. And if you're filtering at the input of each buck, it makes the main pi filter not as critical. But like I said, that's a lot of guess and check and a lot of simulation. What plugins on KiCad do you use frequently? The only one I have right now on here is the KiBomb one, which is amazing. I also use KiKit for panelizing, and then I use the oh, you can't see my screen. Well, it doesn't matter. I use the KiBomb, I use KiKit, and then I also use the KiCad Actions plugin, which has a few cool ones, but it has the Stitching Vias plugin, which is what I was talking about earlier, which is super helpful. Any future design review? Yeah, I mean, anytime I get enough submissions and I have time to do a stream, I like doing these, so I'll certainly do some more in the future. As long as people obviously like them, I'll keep doing them. Anything else? Well, it does not seem like there are anything else, so cool. So yeah, I appreciate everyone for tuning in. Let me know any other suggestions you have. Let me know any design reviews that you want to have me review. But otherwise, one last question. Regarding stitching vias, are the distances important to block certain frequencies? Yes, that depends on what all is on your board. There's a rule of thumb. It needs to be like half the size of whatever the highest frequency wavelength is. I forget. I've never had an issue with that. And that's why I said when I mentioned to add them, it sometimes can be an issue. But on that specific board, it didn't really matter because there wasn't anything super fast. And that's also why randomizing the stitching vias can help, because it helps avoid consistent resonance between them. But that is only when you get into really high speed, and it's not something that I've ever run into, so I wouldn't stress that too much. But yes, it can be an issue. How do you feel the possibility of someone using the wrong cell type in the wrong cell type in the board that I was just looking at, yeah, I mean, that wouldn't be good. Because if you're designing it for a specific cell type or chemistry, it's obviously going to be an issue. But that should be in the design side anyway. Dave, you look tired. Thanks so much. Yes, tired and still not feeling great. So I will call that a day. So cool. I appreciate it, guys, and I will catch you on the next stream or the next video. Have a good one, guys.